Hey guys, welcome back for more right triangle trigonometry. Recall yesterday we took a look at the three trig ratios, sine, cosine, and tangent. And we said that those trig ratios compare two sides of a right triangle based off a particular acute angle in that right triangle. Well, today we're going to take a look at the inverse trig functions, which return the measure of an acute angle based off a pair of sides from that right triangle. So the inverse sine function returns an acute angle that produces a given relationship between the opposite leg and the hypotenuse. Likewise, the inverse cosine function returns an angle measure based off the adjacent leg and the hypotenuse. And finally, the inverse tangent returns an angle measure based off the measurements of an opposite leg and an adjacent leg. So on our graphing calculators, we can compute these inverse trig functions quite simply. We want to find the angle between 0 and 90 to the nearest degree. It says that the sine of theta is equal to 0.407. Well, now to get theta, our actual angle measurement, we have to take the inverse sine of both sides. So when we take the inverse sine of 0.407 on our graphing calculators, we can do that here in just a second. We'll pull our graphing calculator over and we'll find that sine function. Right above it is the inverse sine. So if I hit second function sine, I now have sine to the -1. And I'm just simply going to type in my 0.407, close up my parentheses, hit enter, and I get 24 degrees. So 24 degrees is the measure of the acute angle that produces an opposite leg that is 0.407, the length of my hypotenuse. Now the next one says cosine theta equals 0.987. So again, to undo the cosine, I'm going to take the inverse cosine. What I do to one side, oops, I got to do to the other side. So that's supposed to say inverse cosine. So we're going to take the inverse cosine of 0.987. And again, back to our graphing calculators. Second function, cosine, gives us the inverse cosine, 0.987. And hit enter, and now we have our 9-degree angle. So there's a 9-degree angle that produces a relationship between the adjacent leg of 0.987 times the hypotenuse. Next one, you guessed it, we're going to take the inverse tangent of 2. And when we go to our graphing calculator for that, we take the inverse tangent, hit second function tangent, and then enter. It is a 63-degree angle. Okay, so let's jump into some practical examples here. It says consider the right triangle ABC. We'll cross off that word hypotenuse, in which BC is 5, AC is 15. Find the hypotenuse, which is AB, and then find the measure of angle B. All right, so we're just going to simply use Pythagorean theorem to get the measure of our hypotenuse. 5 squared plus 15 squared equals C squared. That gives me 25 plus 225 equals C squared. And we're going to take the square root of that sum. So the square root of 250 equals C, which is our hypotenuse, and our hypotenuse then will be equal to, let me find it, 15.81. So there's our hypotenuse. Now let's find the measure of angle B. So finding the measure of angle B allows us, to find the measure of angle B, we can actually use any one of our inverse trig ratios now that we have the measurement of all three sides. So I could start off by saying the inverse tangent of the opposite leg of B, which is 15, divided by the adjacent leg to B, which is 5. I could do that. Or I could take the inverse sine of the opposite leg of B, which is 15, over the hypotenuse, which is 15.81. Now, just to show you that these will give us the same result, so let's go to our graphing calculator here. And we'll start off by taking the inverse tangent of 15 divided by 5. And that gives us our 71.5. And now we'll take the inverse sine of 15 divided by 15.81. And we should end up with a very close to the same. So we get our 71.58 and 71.56. So we're going to say that the measure of angle B is equal to 71.5 degrees. Now, if we wanted to use cosine for this, we could have done the inverse cosine as well. Then the adjacent would have been listed over the hypotenuse. So that would be 5 over 15.81. I'll let you confirm that that is the same measurement for angle B on your graphing calculator. All right, our next example says find the measurements of the acute angles of a 3, 4, 5 right triangle. Well, a 3, 4, 5 is a perfect right triangle. So let's go ahead and draw out our 3, 4, 5, the hypotenuse obviously being 5, and we'll label our angles A, B, and C. So let's start in by finding the measurement of angle A, and again, because we know all of our sides, it doesn't matter which ratio we choose. So I'm going to find angle A by using my inverse cosine, and I'm going to say it's the adjacent leg, which is 3, divided by my hypotenuse, which is 5. Then I'll use to find angle, oops, sorry, not angle C, sorry, not angle B, but angle C. Let's find angle C by using our inverse tangent. So we'll say the inverse tangent of opposite, which would be 3, over the adjacent leg, which would be 4. All right, let's go to our graphing calculator here and see what we get. We'll take the inverse cosine of 3 divided by 5, or if you want to change that to a decimal, you could do 0.6 as well. That gives me 53 degrees. And next we'll take the inverse tangent of 3/4, or let's just do the decimal equivalent of that, 0.75, and we get 36.8. So 53 and 37 if we're rounding. And now that should make sense. These two should actually add up to equal 90 degrees, because if you remember, the two acute angles of a right triangle should add up to equal 90. All right, here we go. Example 3, we got a hawk that's cruising at an altitude of 215 feet. Now, an altitude means it's the vertical distance to the ground, so we're going to go ahead and label that at 215. Spots prey directly at a slant distance. So the slant distance is like the distance along the hypotenuse. And that's going to measure 416, oh, just kidding, 406, I'll change that, 406 feet away. Now, we want to know the angle of depression of the prey as seen by the hawk. So keep in mind, your angle of depression is always the angle below the horizontal. So let's draw our horizontal line of sight there. And the angle of depression now will be this angle here between the horizontal and the line of sight down to our prey. So we'll just say it's a fluffy little bunny rabbit. There's its 2 ears and its legs and a cottontail. And we want to know this angle of depression. Well, the angle of depression is actually always equal to the angle of elevation. So this angle down here from the bunny rabbit up to the hawk is the same as the angle of depression from the hawk down to the bunny rabbit. So if you remember this from geometry, these are alternating interior angles. So I can find either of these two angles and they'll actually be the same. So I see that I have a right triangle here. If I drop that vertical straight down to the ground, and this is my opposite leg, and here's the hypotenuse. So O and H would imply that I'm going to take the inverse sine of 215 over 406, and that will give me my angle of depression from the hawk or elevation from the bunny rabbit. So here we go on our graphing calculators, our inverse sine of 215, divide that by our 406, and we'll get our angle of depression to be 32 degrees. So this angle here measures 32 degrees, and same thing from the bunny rabbit back up to the hawk is 32. All right, example 4 puts us in Chicago, the tallest building in the United States of 1,450 feet. So we'll just draw a nice little building here. Sears Tower's got a couple antennas on the top, and that distance off the ground there is 1,450 feet. All right, next we are planning to stand 5,280 feet away, which is exactly 1 mile, but we're going to measure that in feet to keep our units the same here. And we want to know at what angle must you look up to see the top. So if I'm standing way back here, this angle is my angle of elevation. And I'm looking to find that angle of elevation. I notice that this again is a right triangle. My opposite leg is 1450. My adjacent leg is 5,280. Now I'm going to use my tangent ratio because that's the one that compares the opposite and the adjacent. So because I'm looking for an angle, I'm going to take the inverse tangent of 1,450 divided by 5,280. All right, to the graphing calculator we go. Inverse tangent There we go. 1450 divide by my 5280, and I should get about 15 degrees. All right, so this angle of elevation is approximately 15 degrees that I have to look up to see the top of that tower.